Hello everyone, and welcome to session 2, and in this session we're going to look at a practical guide to auditing. So let's start with the overall audit process. You can think of this as having 4 main stages. There's going to be some initial engagement with a client, then you're actually going to get to the heart of it and do some auditing and produce an initial report. This will be given to the client and they will have the opportunity to make any changes. You will then take the changes, be able to check those, and you can produce a final report. But the process needn't end there, because we can then go and give some post-audit advice about bug bounties and how to get into production. So the initial engagement is where you agree the scope with the client and gather information, documentation, and get a good understanding of the application. And this really is vital that you make the most of this to get as much information as you can from the client. The second stage is going to take the most time, and here you will use code inspection, maybe some tools, to find as many issues as you can within the code. And the deliverable from this stage is the initial report. And in this report you detail the issues you have found. And typically for each of these issues you will note why this is an issue, how to reproduce it. You will produce a risk rating for the issue, and hopefully you'll be able to give a recommendation on how to fix the issue. Of course, when we give issues to the client and give recommendations, it is up to the client to decide what changes they want to make, and indeed whether they want to make any changes at all. So let's look now at how to approach the audit. There are some main stages to the audit process. Initially, you're going to want to focus on understanding the logic of the system and the relationships between different components in the system, and you need to focus on getting this understanding rather than immediately looking for issues. Look at function names, look at function signatures, and the structures to try to get an idea of the architecture of the code. Now, there's a question about whether you want to consult a specification. I think on the whole this is worth doing, but you should bear in mind when you do this that there could be errors also in the specification, so do be a little skeptical about that. Then when you have a good understanding of the code and the system and how it is worked and what they are trying to achieve, then you can take a deep dive into the code itself. Start to look at all of the files individually, work through specific functionality and get a good mental map of the transaction flow within the code. It helps to be able to run tests so you get an idea of the flow of the application as well. And you will also want to use any appropriate tools. Now, when we're looking at ZK apps and auditing those, this does differ from the traditional smart contract audits in a number of ways, and I've given you an idea of this in the table. Of course, you need to remember that we are doing off-chain computation and proof generation. We'll have different key vulnerabilities or potentially in the code, such as under constrained proofs. The tools we are going to use or that are available to us could be very different. We need very specialized tools for analyzing zero knowledge projects. Generally, there is more expertise required because of the cryptography involved. And what the 2 main areas we're probably going to be thinking about are the soundness of the proofs and the correctness of the computation, and also privacy guarantees. But having said that, those are the ZK aspects, but you shouldn't forget the other aspects of applications that still apply when you're auditing code. So you need to think about things like operational security, about any logic errors within the business logic, Web3 vulnerabilities generally, And then also on top of that, we have the ZK specific issues. So thinking about some techniques we can use when we are doing, say, code inspection, it's one of the most crucial parts is the mindset of the auditor. And there are different mindsets that we can use. We can take some different approaches to the audit. So, for example, we could take more of a hacker mindset, thinking about how we can damage the system or exploit vulnerabilities. We can take more of a formal verification mindset, looking at the correctness of the system as a whole. We can also look at the general architecture of the system. So digging into those a little more, if you're thinking as a hacker, you're taking that kind of mindset, some useful questions you may want to think about and may want to get answers for are, how is this project not supposed to work? And so this may be something that the developer hasn't really focused on, but if you're trying to exploit vulnerabilities, this is something that could be useful to think about. Are there any use cases that shouldn't be available to regular users? Administrative functions, for example. Are there any limitations on the sequence or the frequency of function calls that can be done by the user? And what constraints are there on the input that the user can supply to the functions? And which parameters cannot be controlled by the users? That's going to limit the possibilities of damage that a hacker can do. Taking a more of a formal verification mindset, you could look at, say, the invariance within the protocol. What has to be true if our application is working correctly? And what may help at this stage is to create a state machine diagram. Then from the system architect mindset, think about integrations. Are you interacting with other systems? And look at this in quite a skeptical way. Don't assume that any integration is going to be correct or that information you're getting from elsewhere will be correct. If you have dependencies, could these fail? And what is likely to change about the system over time? Now, some general strategies that I have found useful to help discover issues. One is to anticipate what a developer may have done in error or any shortcuts they may have made. A useful point to look at are the user inputs, because really these form the attack surface that an attacker can use. So look at those and also look at potential vulnerabilities. If there are well-known vulnerabilities, then keep those in mind. Of course, you're going to be working as a team, so make the most of that, and use existing resources, maybe existing audits. Look at the unit tests. Look at the quality of the tests. What were they trying to do? Did they just try to show that certain functionality has worked? Or were they trying to break the code? Were they really digging in and testing as hard as they could of the code? And generally speaking, maintain a healthy skepticism about the code. Some questions you may want to ask yourself are around the entry points of the system. Look at the interactions with any external systems or components, and particularly look at the access control mechanisms. It is very likely that there should be some type of access control. You may want to restrict who can call particular functions, so you need to be very clear about that. What can be useful is to map out the major functional pathways through the code, and also to think about the potential bad states that the system could get into. And if you understand what a bad state is, what a problematic state is for the system, you can sometimes work back and then look to see how that state could come about. To help with that, a state machine diagram may be useful. and also be thinking about cross-referencing what you are seeing with the documentation. Does the documentation and the implementation match up? And there are tools that can help you with this, and also cross-reference what you are finding with what the tools are telling you. Some areas you may want to pay particular attention to are things like access control, complex arithmetic, especially if that's financial, handling of data types. If you're casting between data types, is there a possibility that you can get truncation? What about error handling? Is that being done correctly? Are we allowing for all the errors that could happen? Are there non-standard patterns being used by the developers? And have the developers modified or failed to use standard libraries? Now, it could be that the developer has made some type of assumptions, and it's good to challenge these assumptions. So they may have made assumptions around the order in which functions are called, or maybe the frequency of those calls. They may have assumed that access control is being correctly implemented, and they may have made assumptions about the values of parameters that are being passed into functions. So I've mentioned access control because this is a very common source of problems. And so it helps to really focus on this and to find out what roles are there in the system. Are these roles comprehensive, and are they consistent? And are these roles documented? Obviously, if they're documented, this is going to make your life much easier. If they're not documented, it's worthwhile documenting them for yourself and asking the client if this is indeed correct, if these are the roles that they intended. Now, in addition to that, there are some ZK-specific areas we need to think about. And the two main impacts we can potentially get if the ZK aspects are incorrect are that we could get a loss of soundness, so there could be an incorrect proof that is going to be accepted, or we could get a loss of confidentiality where we don't have the zero knowledge aspect of the proof. And a common issue in ZK systems is that of under-constrained code. In ZK apps, the issue of under-constrained code is particularly relevant because we have a potential mixture. We have some code that is provable and forms part of the circuit, and some code that is not designed to be provable. And it is vital that we get this distinction correct. Let's turn now to a technique that we're really hoping that you are going to want to get involved in, and that is the idea of community auditing. So this is a new approach, and it is much less formal than a full audit, but is aimed to give some of the benefits. And it draws upon the experience of your fellow developers who may be able to spot issues that they have already known about, that they have experienced, or that they have been affected by. And it is important, if you are talking to your fellow developers and giving feedback, that this is done in a positive and factual way and is free from any kind of judgmental language or opinions. Any kind of negative comments to a colleague about the code could make it much less likely for them to take that issue on board and to take advantage of it. Now, I think the majority of your time, if you are auditing code, will be spent on code inspection. But there are tools available. Perhaps we shouldn't rely on these 100%. I think we're still, as humans, better than the tools. But it's worthwhile using those that are available. And so some tools that you may find useful, we have tools for languages such as TypeScript, so we have static analysis tools and linters that will help make the code more readable. Testing techniques are important, and so things like fuzzing techniques could be useful. And then there are specific tools that will help look at zero knowledge specific issues. And a couple of these tools are Vanguard and Picus from Veridice.